All right then. So I have one question in mind for today.
Okay.
You can see there's the beginning of the class here, and this can be in Swift today.
Okay.
I want you to write a stopwatch class with the functions start, stop, and get elapsed time, such that get elapsed time always returns the cumulative time that the stopwatch has been running.
Okay.
That makes sense?
Yeah.
So I have a few test cases here if you want to make sure that those make sense to you.
Let's see. Start. Okay. That expects 2.
Right. So it runs for 1 second here, and you stop, and then you start it again, and it runs for 1
Oh,
more second.
okay. Sorry. Yeah, I thought that was like stuff. Okay. Yeah.
Yeah.
Okay. Got it. Yeah. Okay. Sounds good.
Cool. And then you'll also note that I call get elapsed time while the stopwatch is running. So
Okay.
I don't call stop again there. So
Okay.
take it away.
Cool. Let's see. Let me think about this for a minute. So I'm just gonna need some sort of property that keeps track. Wait, there's no like reset or anything?
No. So the functions that you see are that's the whole API for this class.
Okay. Let's see. Okay. So we need some sort of variable to track the total time. And the start is just going to increment that by 1 and sleep 1 second. And just basically loop until you hit the stop.
So I'll stop you right there. The looping isn't the direction we want to go. I'll show you. We have this helper function here now that gives you the current system time.
Oh, okay.
So
okay.
I want to use that instead.
Okay, so then we're going to need 2 variables. 1, the cumulative time, and 2, the current start that we're on's time. So as soon as we start, we're going to get the system time. And as soon as we're going to have another Boolean that lets us know whether we're going or not. Actually, do I need that? Actually, the stop can just... Okay, yeah, so when we hit start, we're going to track the current system time. And then once we hit stop, we're going to track that time and subtract the time difference and just add it to our cumulative time.
Makes sense.
And let's see, for the case where you call get elapsed time while it's still going, get elapsed time should also call the system time and subtract it from start, I guess, or from the start time that we saved. That should work. So we're going to need, this is out.
Oh, try this one.
Thank you. Total elapsed. It's going to be double. And we'll start it out at 0. And we're going to need what about the case? Can you hit start multiple times in a row?
Yeah, that's a good question. Glad you're asking this so early. Well, technically you could. What do you think? What do you think should happen if that happens?
Okay, so if we're already going, then it shouldn't do anything, I think.
Okay, so kind of fail silently.
Yeah.
Yeah, that's one way to do it.
So, is that the usage of like the stopwatch we want to go for? The spec, I guess.
Well, I haven't defined that yet. That's
Okay.
for you.
Okay.
For you to pick.
Okay, so I can decide that.
Yeah.
Okay. So in that case, we also need to. Also, if we haven't started and we hit stop, we gotta make sure. Okay, so maybe a couple booleans too that say whether we're currently going, or one boolean if we're currently going. Okay, current start is going to be also double. And now it returns like the time from like a certain time in seconds, or what is?
Yeah, it's some time since 1970.
Okay, 1970. Okay,
and it's in seconds. Yeah.
okay, cool. Started. Just start that out as false. And we need the. Do we even need to store the stop time? No, I don't think we need to store. Actually, yeah, we do. Stop time. Also, what do we return if we haven't started yet?
In the get elapsed time?
Just 0?
Yeah, 0 makes sense.
Okay. That should be handled already, I guess. Okay, so let's do our start. Okay, so when we start, we just want to store the current time into our start variable. We gotta make sure that it's not started already. Okay. Stop if. Oh wait, we gotta start it. So we'll do that in here too. So if watch started, then we will flip the boolean to false, and we'll track the stop time. Then we just need our get elapsed time. Okay. Which will just take the stop time and the start time. So the stop time is going to be later, so this is going to. Wait, this just print? Alright, it returns, right?
It returns the value, yeah.
Return. Stop guess I could have just called that start time. And,
All right. So is that your final answer?
let me think for a second. Make sure. So, okay, so we're going to start it. If it's not started already, we store the time, and then we flip the started and stopped. If it's started already, then we stop that, and we store the time, and get the time just subtract 2. And in the case that it was never started, oh wait, we don't have a stop time in this case. So we need to see if watch is still started. Then we need to take return now minus start time. Oh wait, but also if we never start, then oh wait, no, that's already good. Okay, start time. Oh, wait. Start. Otherwise, we just do what we did before. Stop time minus cur start. Okay. Now that should be.
Okay. So the same as the first test case.
Mm-hmm.
It breaks in this test case and a few others.
Okay. Let me see. So, in this case, we're still, that's our current state. Oh wait, I'm not even using the total elapsed. I forgot about that. That was the whole point. Okay, so I need to, every time we stop, we need to add to the total elapsed. Let's see, every time we start, we add to total elapsed. And when we get elapsed time, we need to return total elapsed. We just need to add total elapsed to this basically. Stop time. Yeah. Okay, and then we get elapsed time. If the watch is already stopped, then we shouldn't be doing this. We should just be returning the total elapsed time.
Yeah. So that fixes a few test cases right there.
This we should add total elapsed time.
final answer?
The way you're saying that makes me.
Maybe, maybe not.
Okay, let me run through it one more time. Okay, so we start. Sleep a second. Okay, we start. The watch is not started, so we set our current time to now. Watch start is true. We hit stop a second later. Watch is started. So now it's stopped. Stop time is now. We add the stop time, which is a second more than the current start, to total elapsed time. And we sleep 1 second and start again. Okay, we start again. The watch is not started at this point, so we record the current time, the start time. I'll get elapsed time. Watch is currently started, and it's a second later, so a second later, that's 1 plus the total elapsed time, which is another 1, so 2. Yeah?
Yeah. Cool. Well, so if you want the kind of errors where you call start twice to fail silently, this is a correct solution.
Okay.
This is I would say, a near ideal solution.
Cool.
Looking at this, if you had any code to remove that was superfluous, do you see any code like that?
Let's see. Well, we could probably remove this.
The stop time?
Yeah.
Yeah. You don't have to write it out.
Okay.
We can imagine what the refactor would look like.
Yeah.
All right. So another talking point. So when I run this, I run this first test case, and we expect 1, but we end up getting like 1.000 like 7.
Right.
So what's going on there?
So it's a double, so it's just going down to like whatever that now returns up to.
Are you saying it's like a floating point kind of rounding error?
Mm-hmm.
Okay. Well, 1 can be represented in every kind of double notation, every kind of double system that I've seen.
Mm-hmm.
So that's not quite what's happening there.
Okay. Well, it's like I'm saying, like it's in between like a second or something.
Mm-hmm.
So like in the system time, it's not just going by like second. It's probably going like every 0.0000 seconds. So
Okay.
like when you hit the now function, it's not like perfectly on a second.
Oh, so you're saying the system timer?
Yeah, that's what I meant.
It might be because of the system
It's
timer.
not by like per second. It's like
Yeah, that's a good point. But on a similar note, one of the things that I was looking for is the scheduling of like sleep. Like this sleep is.
Oh, that's what you're saying.
Yeah, it's not gonna.
It's not gonna like execute like exactly on time. Is that
Yeah.
right? Okay.
Exactly.
Mm-hmm.
So that's something to be mindful of.
Okay.
Normally, it's pretty accurate, but on certain systems, you can there can be a lot more room for error here. Maybe on embedded systems or in like old web browsers.
Mm-hmm.
All right. What else? Cool. Well, so we've cleaned that code up. So thinking about this from like a user experience point of view, user experience being like I'm a developer, I'm using this code, and I want it to be like easy to use. What do you think are some other ways that we can handle this case where like you call start twice? Because you probably don't intend for the consumers of this library to ever do that, right?
Mm-hmm. Let me think. How else would I handle when they call start twice? Is that
Yeah.
Besides using a boolean, or
Oh, you mean like returning true or false to if it was valid?
yeah, like well, I'm not really understanding the question actually.
It's more of an open-ended question,
Mhm.
and
Like from a code design point of view, or what?
like from a developer point of view, like
Okay.
if you're using some library and
Mhm.
something broke without you knowing, like
Oh,
how would you
okay.
want it to let you know that you were using it wrong?
Okay.
So returning true or false, that's a pretty
Yeah.
good way to do it. I've seen that in like C
Mm-hmm.
and C++.
Or
Where,
maybe
like,
returning like an int with like that relates to some error code or something.
yeah. So
Okay.
returning something like that. Another way you could do it is maybe like print out something to the console or throw exceptions.
Mhm.
So it sounds like exceptions aren't too common to throw in userland
Mhm.
in Swift.
Yeah. No.
So I wasn't quite expecting that answer.
Yeah.
But yeah, those are all things that you can do.
Mhm.
So cool. So I guess we're done with that problem. Got through that fairly quickly, which I'm happy with.
Cool.
So what do you think? What are your thoughts? How do you think it went?
I think it was okay. I definitely missed the total elapsed time part. Like that was like the whole scope of the problem too, so that was pretty bad. But when you reminded me of that,
Yeah.
and,
So initially you were talking about having some kind of counter,
mm-hmm.
and I guess looping and incrementing some value. How were you imagining that working?
So I was just going to have like a loop that you start it, and it's like a while loop. And it's like while some boolean isn't, or like okay, so you switch like watch started to true when you hit start, right?
Mm-hmm.
And then you start looping through this loop, and inside the loop I'm incrementing by 1, and then sleeping 1 second, and then whenever you stop, it flips that boolean, and then or actually wait, that wouldn't really work because then it would just get stuck.
Yeah. Have you done any like multi-threading?
A little bit, yeah.
Yeah, because doing that you
would
lock up the whole thread,
would, yeah.
and you lose a lot of accuracy too.
Yeah, you're right. That wouldn't work.
Yeah.
You would need some way to stop it.
Yeah.
Or, yeah, no, that wouldn't work.
Cool. I just wanted to hear a little bit more about how you envisioned that working. But yeah, so this solution here is great. I can give you a little bit more backstory or kind of perspective on this question. So I think you did pretty well on this. It gave you a pretty big hint early on to use this this function here. So I don't always do that. I think that helped a decent amount. But before we dove into any of this, you were asking some pretty good questions. So you thought through this pretty systematically and came up with your instance variables. This one was a little extra, but not too much harm there. And you considered the case where start gets called twice. Some of the things that I've seen, apart from people trying to get through the whole looping, go down the whole looping rabbit hole, is also using like an array of times and then summing those up later, which is weird, pretty unnecessary. So I think your approach here was pretty good, and timing wise, I think you were pretty on par with like kind of how much time people normally take on this problem. So I would say you actually did really well on this problem. Cool. Just make sure you don't go down any rabbit holes like the whole looping.
That was just like my initial thought, but I didn't think it through. But yeah, as soon as we started talking about it, I was like, yeah, that wouldn't work at all.
Yeah, and I guess I made it pretty explicit early on, but always good to ask clarifying questions about the problem. And you asking like what if you call start twice is a great example of that. So I guess my feedback for you is just I don't really see any really big issues. I'd say just keep programming. If I had to give one piece of feedback, I guess maybe you could ahead of time think a little bit more about the instance variables. and kind of imagine like what you need and what you don't need.
Right.
So in this case, this didn't really add much complexity, but if you're holding on to extra state, especially if it's like it's some kind of mutable state on an instance, like that can really lead to complexity fast.
Right. Yeah.
So that's I guess my one piece of feedback. But yeah, it's pretty good.
Cool.
All right. Hi guys, thanks for watching. I wanted to tell you all about Build School, which is a boot camp that Chris, who you saw earlier in the video, is a student at. So Build School, which you can find at buildschool.io, and that link is in the description below, is a boot camp where after coursework, these students are working on iOS and Swift development right now. After the coursework, the students work on contracts that Build School has, so you get real world experience, before you even get sent out into the field. So yeah, if you're interested in learning more, I encourage you to check it out and let them know that Coach Matt sent you. Thanks. Monty, stop scratching at the door.